let's talk about special cases whenever we're factoring quadratics. There are two cases that we're going to look at today. The first one is the difference of squares, and the second one we're looking at is a perfect square trinomial. Let's take a look at those difference of squares first. A difference of perfect squares is something that looks like this: ax squared minus c, where a and c are both perfect squares. The formula for doing this would be the square root of ax squared plus the square root of c times the square root of ax squared minus square root of c. And that looks like a lot. I know, there's a lot of radicals going on. There's a bunch of variables. When we actually solve them out, yes, we will use this formula, but it's going to feel much simpler. What we're doing here is we're taking the square root of our first term, and that goes in the first slot. Then we take the square root of our second term, that goes in the second slot. And then one of the factors has addition, the other factor has subtraction. And that's it. And that's the formula. That is the process we are going to use for all of our examples. So let's take a look at that first one. Our first example is 16n squared minus 9. So, just like we saw earlier, our coefficient here is a perfect square, coefficient here is a perfect square. The process for making our factors is we're going to square root this, which will be 4n, and we're going to square root this 9, which will be 3. And we're going to use this for the first slot in our factors, and we'll use this for the second slot in our factors. One of them has addition, the other one has subtraction, and that is it. We are done. That is the factorization for 16n squared minus 9. Process again. Square root your first term, square root your second term. First term goes in the first spot for each of the factors, second term goes in the second spot for each of the factors. One of them's added, one of them subtracted. For our second example, we once again have a perfect square up here, 4m squared, and a perfect square down here, this 25. Since they're subtracted, it is a difference of squares. We're going to use the same process we did before. Square root of 4m squared is 2m, and the square root of 25 is 5. 2m goes in the first slot for each of our factors, and 5 goes in the second slot for each of our factors. One of them's added, one of them subtracted, and we're done. This is the factorization for this quadratic. Okay, for our last example, it's going to look a little bit different. We have x to the fourth minus 100. Well, 100 is clearly a perfect square, but this x isn't squared. It's raised to the fourth. So are we stuck? Is there nothing we can do? Well, actually, if you remember back to the video where we went over the exponent rules, x to the fourth is the same thing as x squared squared. And then we can have minus 100 over here. So now we have something raised to the second power minus a perfect square. Perfect square over here, perfect square over here. And when we take the square root, we're going to take the square root of all of this, not just the x squared on the inside. It's the x squared squared. So what is the square root of that? It would be x squared. Square root of 100 is 10. X squared goes first in each of our factors, and 10 goes second in each of our factors. One of them's added, one of them subtracted, and we are done. It almost looks like we could continue because we have x squared minus 10, but 10's not a perfect square, so this isn't going to get factored out any further. If 10 was a perfect square, if we had something like, let's say 16 in here. Actually, you know what? Let's just do an example where it continues on. So let's do an example where we actually do get to continue on some extra steps. We have, let's do x to the fourth minus 256. Our x to the fourth is the same thing as x squared squared, and 256 is the same thing as 16 squared. So when we square root both sides, we'll have an x squared and a 16. X squared goes at the beginning of each of our factors, and 16 goes at the second part of both of our factors. One of them's added, one of them subtracted. But we're not quite done yet because this is also a difference of perfect squares. You can't do anything else here. This is done. So we'll have x squared plus 16. That'll be part of our final answer. But over here, we're actually going to expand x squared plus 16, or I'm sorry, x squared minus 16. We're going to expand that out. We'll have the square root of x, the square root of 16. One of them's added, one of them's subtracted. And this gets put down here. So we'll have x plus 4, x minus 4, and this, with 3 different factors, is the final factorization of our original quadratic. Let's talk about perfect square trinomials now. A perfect square trinomial is where you have a quadratic in the form ax squared plus bx plus c such that 1/2 of b squared is equal to a times c. This looks like a lot. I'm going to have this written off to the side, and this is the formula we're going to follow, or this is how we're going to check for a perfect square trinomial. Once you know it's a perfect square trinomial, the factorization is going to be the square root of this, so the square root of ax squared, the square root of c squared, and if b is positive, we put an addition sign here. If b is negative, then it gets a minus sign. So this sign is dependent on what sign does b have in our original quadratic. So let's take a look at a couple of examples so we can see how this works out. All right, let's take a look at our first example. 1/2 of b is 2, squared is 4. So this value is 4. A times c, which is 1 times 4, is also 4. Since they're equal, this is a perfect square trinomial. What we're going to do is square root our first term, get x, square root our second term, get 2, and they are going to be added together because our middle term is positive. Mark that as squared, and that is it. That is the factorization of the quadratic. It's that quick, it's that simple. And this is why I wanted to bring up these special cases, because you don't have to go through the quadratic equation. You don't have to go through factoring by groups. There are some quadratics that if you recognize as a perfect square or you recognize as a difference of squares, they are much faster to factor out. Okay, let's take a look at this one. Very, very similar to the last one, and that's on purpose. The 1/2 of -4 is -2. -2 squared is a positive 4. We have a positive 1 times a positive 4 for our a times c, which is also 4. 4 is equal to 4. This is a perfect square trinomial. We're going to follow the same procedure that we did last time. Square root our first term. The square root of this is 2x. Square root our second term. Square root of 1 is 1. And is it going to be added or subtracted? We look at our b term. It's negative, so our final answer will have a subtraction in it. 2x minus 1 is the 2x minus 1 squared is the factorization of 4x squared minus 4x plus 1. Let's check out our next example. We have 100 x squared plus 180 x plus 81. All right. Is there anything I can factor out of this to make it simpler? It does not look like there is. Okay, so we're just going to be dealing with some big numbers for this example. We're going to check and see if it is a perfect square trinomial. 1/2 of 180 is 90, and then 90 squared is 8,100. 100 times 81 for our A times C is also 8,100. Yay! It's a perfect square trinomial. We can factor this out using the perfect square formula. So we're going to take the square root of 100x squared, which will be 10x. Take the square root of 81, which is 9, and they're going to be added together because our b term is positive. Make sure we toss our square up here, and this is done. That is the factorization for 100x squared plus 180x plus 81. It is 10x plus 9 squared. For our last example today, we're going to check out 200 m to the 4th plus 80 m to the 3rd plus 8m squared. All right, well, this isn't a quadratic, this is a quartic. It's got something raised to the 4th power. So let's go ahead and see if there's anything we can factor out. We can definitely factor out 2. We can factor out a 4. We can factor 8. We can factor 8 out of the 200. We can factor 8 out of the 80. And we can factor an 8 out of the 8. We can also factor an m squared out of everything, because this has an m squared in it. This is m squared squared, and this is m squared times m, and then this is just an m squared. So let's factor out an 8m squared. 200 divided by 8 is 25, and then m to the 4th divided by m squared is m squared. Then we have 80m cubed divided by 8m squared. We have 10m, and lastly we have, that's just 1 at the end, because 8m squared divided by 8m squared is 1. Now, let's check and see if this quadratic inside is a perfect square trinomial. Half of 10 is 5, squared is 25. Then for A times C, we have 25 times 1, which is also 25. They are equal to each other. This is a perfect square trinomial. So let's factor it out like a perfect square. Square root of 25m squared is 5m. Square root of 1 is 1. They will be added together because our b term is positive. Toss our square up there, and don't forget to drop down the 8m squared that we factored out earlier. And there you have it. That is the factored form of 200m to the 4th plus 80m cubed plus 8m squared. That's it for today. If you found this video to be helpful, make sure you like, subscribe, and if you have a topic you want me to cover in the future, leave it down in the comments below. As always, have a fantastic day.